Thank you, everyone. And let's go inside. The subject of today, we're going to discuss around performance. Why is it important? Why performance testing is complex, and what we can do to help people to achieve those goals, and how to help them in this painful task. So as I've said, I am one of the HCL1 test product manager, and so HCL1 test is a set of portfolio, and one of the capability it has is to do performance testing. So performance, let's talk about performance and why is it important. So obviously the probably things that we all already know, but yeah, if you ask to yourself, why do I like this application, or maybe why don't I like that application, it's probably because you will find the information you're looking for easily, or the service that you expect it to give you, like, for example, book a flight ticket or anything like this. It's probably because it does the job. But immediately after that it's because it's quick, right? It's fluid, it's reactive, it's going fast. And so very probably the performance of the application that you're using is a huge part for the reason why you like that application, right? Or why you don't like it, for example. So that's obvious, that's in front of the scenes, but behind the scene, if you are producing a web application on the internet, you might sooner or later will have to take care about search engine optimization algorithm, because indeed you want to be well ranked by Google, for example, so that your application can be visible. And yeah, they are measuring the page load time that your application is doing, and basically Google and others doesn't want to deliver bad results because they would be associated with a poor performing result. They don't want that to happen, right? So the speed of your application is one of the metrics they use to how they rank your pages. So performance is really important so that you can be achieve a high ranking goal in this. Another thing really important is what we call the conversion rate. Conversion rate is out of the total number of visits, the number of visits that actually is converted to something, whether it's, for example, purchasing something from your application or clicking next, whatever. It's the action that you expect the users to take. And there are some statistics that showing that, for example, if you have a 2 seconds page, if your page loads within 2 seconds, you would have something like 2% of conversion rate. But when this page goes up to 4 seconds, for example, your conversion rate would fall below 1%. So that the performance of your application is really important to maximize the conversion rate and make the probability that users would bounce off your application as low as possible, right? And the very last thing is about the carbon footprint. Now we are far away from thinking that the internet is free regarding the carbon emissions. It's not free. There are lots of applications on the web that are giving you numbers about whether your page is, emitting how much carbon dioxide. It is obvious that heavy pages, slow pages, are having a significant impact. So you really should be sensitive to making your application quick, smart, because it is having a better footprint. So for all those reasons, the performance is really important. This is probably obvious things, but I was thinking it was, good to refresh. And so if it's so important, so then let's test it. Let's do performance testing of your application. The thing is that the performance testing is not quick and dirty task, something that you can do in 15 minutes with a single computer on a table. Unfortunately, it's not that. It's not the case. Probably because your system under test is possibly really complex. Possibly it's distributed all over the planet. And possibly because your performance test, you might want to use thousands of virtual users. And in order to be able to inject the thousands of virtual users in parallel on your system and the test, you might have to use what we call data injectors, and distribute those injectors over a platform. So this activity is need to be planified, you need to be managed. And probably one of the first things you need to do in this activity is also to express the requirements, because obviously a performance test only evaluate the system's compliance against something which is the requirements, how much virtual users you want, how much users you want to achieve, you want to have in parallel, right? For example, I want 1,000 people be connected at the same time on my application, and those all of them are having a quite nice experience. Say, for example, page load time should never be more than 2 seconds, for example, something like that. So you need a platform like this, and you possibly also require some virtual service virtualization, sorry, because your system under test might have some external dependencies, and you might want to stop them. You might have to stop them because maybe they are not available at the time you do the test, or maybe they are costly. Maybe there is a fee associated with each transaction you are doing on them, and you don't want your test to have a cost, really. So you might have to use stubs. So that's quite, not easy, but there are tools for this. For example, HCL One Test Performance is doing all this for you. And then when you run this test, you have to analyze the result. And for example, here is a metrics about the page response time. So you can see that my test is a 3-hour-long test. You can see at the beginning it's going well. The response times are quite low, but then at 1 hour it's going up and up and up. So that I'm happy with that, but it's not enough for me to have real information, and I have to correlate this information with the user load that is applied on the system by range. So for the first range, I am having 1,500 users, and then I go up and up and up. And when I am at 5,000 users, I am seeing my system which is behaving weirdly. The response time are going up and up and up. So maybe something is wrong here. So that's a kind of pattern. But the thing is that if you express a requirement saying that, for example, I want 95% of my request to be below 2 seconds, which sounds to be a reasonable requirement, because we prefer to talk about percentile 95 rather than all the data, meaning that 95% of the requests are below 2 seconds. In this case, your test should be green because the value is at 1.7, meaning that 95% of the requests are below 1.7. So the test is passed. So we would say, yeah, your test is correct. But really, is it correct? Because as you can see, the human eyes can see here, there is something wrong here. Because, for example, if my test runs during 4 hours instead of 3, maybe it would become wrong. And so we are recommending, test automation. It's all about all our business. But that analysis, running a performance test generates lots of data, a huge amount of data over the time. And that manual analysis is becoming a bottleneck. So what we have done is to provide a single click button, an fully automated way to scan performance test results and look for some patterns like this one, so that you're not missing important thing in your test results, right? So how did we build these capabilities? Basically, we are trying to achieve the same visualization that the human eyes is doing when you see two metrics that are correlated together. And so we use the machine learning algorithm because they are very suitable for mimicking what does the human brain and the human eyes, that sort of thing. We made a supervised machine learning, meaning that we trained a huge neural network model, injecting runs, injecting performance test results that have some of them were having the patterns and some others don't, and we trained the model like this one. And so each time you run a performance test, your performance test result is scanned over that pattern detection, and a little notification is made when it contains a pattern like this. And so to start with, we've been delivering 3 main patterns. The first one is the response time lockstep, which is the one we just saw, for example. So you have the user load and you have the response time, which is going up associated with the user load. Your test might be green, but you understand that it might not be scalable. So maybe it's normal, maybe it's managed. Maybe you can say, no, that's normal, but at least the tool is pointing you that your data contains this pattern. The second pattern we are looking for is a drop in the throughput. For example, you have the outgoing byte rate, number of bytes per second, and sometimes when you have a sudden drop like this one, you say, well, during my test, something weird happened. For example, there is a network connectivity issue or something like this. Something's going wrong in my platform or in my system at the test. That's important to know in order not to miss important information. And the last pattern will be we have delivered is what we call high response time standard deviation, meaning that when it illustrates the fact that the response time is not really stable at all, right? So high response time, high standard deviation means the response time is not stable, which might be an issue indeed. So yeah, we delivered the 3 different patterns with the objective that help users to be notified that their runs might be pass, might be green. Everything looks okay, but maybe not actually. It's worth pointing the user to that fact. That's what we recently delivered in our last release.